Hello guys! At first I apologize for not uploading any new videos lately. I'm working 2 real-life jobs at this moment and I also caught a nasty cold, hence my screwed up voice. But don't lose faith in me just yet, the show will go on. In today's episode I will show you a bunch of repairs and as I always do I will explain some things along the way. I have a bunch of defective power tools waiting on the bench, but some other more exotic devices as well. The first patient is this reciprocating saw. My father gave it to me. He said it made a boom sound, the circuit breakers blew and the saw wasn't working anymore ever since. I guess I already know what's the issue, but let's just take a look inside. First I unscrew the casing with my botched up cordless screwdriver. Now we can look inside. The first thing I always do when making repairs is to take some photographs of the wiring and other details. In this way it is often more easy to take the device back together again. Now let's analyze what we can see here. Up here we have a gearbox, which surely works on a combination of a reduction gear and an excentre. I won't open this box, but we will take a look inside a similar mechanism later in the video. The gearbox is powered by a universal motor as it is typically used in power tools of all kinds. Here you see the commutator and the motor brushes, as well as the stator with a part of the stator windings exposed. Inside is the rotor or armature, which has also a fan attached to it. Here we see a black box with what appears to be a simple switch, but if you take a closer look you can see that there is a little knob on it with which the motor speed can be varied. This tells us that a motor control circuit of some kind must be inside the box as well. Since the motor, including the brushes, looks just fine, it's very likely that the defect lies within this box. Therefore, we have to take a look inside. After opening the box carefully, we can see what's going on here. We have of course actual switches to turn the motor fully off and on. But then we have a piece of conductive rubber right here, which can be moved up and down when pushing on the red knob. The little wheel can be used to limit the maximum depth the knob can be pushed to. The component right here is the input filter, and we will take a closer look at that in just a minute. Inside of the other half of the box we can also find a tiny PCB. This is a phase-fired controller based on a triac. The component you see here is not a simple diode, but it is a diac. The two black lines, together with a piece of conductive rubber, comprise a potentiometer. That potentiometer is part of a variable RC circuit, which is used to supply the triac with a trigger pulse of variable phase angle. In that way, the cutting of the sinusoidal grid voltage can be varied, also varying the effective value of the voltage supplied to the universal motor. This is the way in which these motor control circuits usually operate. But I will have to tell you more about the theory of phase-fired controllers in a specific theory video. For now, let's rather take a closer look at this filter component. It is obviously damaged, and I'm 100% sure that it is the reason for the incident my father described. But what is inside this strange thing? Well, it might look like a capacitor, but it actually holds several components, as its label reveals. It is comprised of one class X and two class Y capacitors. Not in this particular case, but often enough a common mode choke is also included. The common lead of the two Y-class capacitors is connected to the stator of the universal motor. What is this filter good for? Well, the phase-fired controller as well as the commutator of the universal motor act as switches, which basically cut the natural waveform of the input voltage. They therefore generate harmonics, which are being superimposed on the sinusoidal waveform of the grid. These harmonics can disturb other grid-powered devices like for example radios and other sensitive equipment. Similar filters can be found in virtually all modern power tools because they are required by regulation, but they are usually not necessary to operate the tool. And since I don't have a fitting filter at hand, I will simply delete it for now. But I have also cut the box so that I can add a filter of different size later. I did that because it will be quite expensive to buy the exact same filter. These components are not off-the-shelf parts. So, with the phase-fired controller directly connected to the power cord and thus to the grid, the reciprocating saw works again. By the way, this is the damaged filter component with the brittle outer layer removed. It looks like one of the capacitors has ruptured. The next patient is again a Bosch power tool, but this time it's an angle grinder from Bosch's professional line. It's a German company, but this thing was made in China. My thumbs down for that. The story is exactly the same as with the Bosch reciprocating saw. It made a loud noise and stopped to work. Inside the enclosure we see very much the same as inside the saw. A switch, a motor control circuit and a filter, connected to a universal motor. In this case the controller is potted, so that we cannot look inside, but I'm quite sure it's a phase-fired controller of some kind. But since it has no potentiometer attached, it cannot be used to vary the motor speed. My guess would be that it either regulates the motor speed or serves as a soft start function for the motor. As you can already see, the filter is again the reason why the tool stopped working. I will again have to delete it, but this time I will at least connect a simple X-class capacitor to the device, which will act as a bare minimum filter until I have something better. After taking the enclosure together again, the angle grinder is ready for operation. The next device is this cheap looking lamp. It's sold by IKEA and mimics the looks of a flickering torch. Friends use it as a part of a toy castle for children. Taking it apart is not a fun job. It clearly wasn't designed to be repaired. As it looks, it's simply a 12-volt 10-watt halogen lamp with an orange glass filter in the front. The flickering is accomplished by a control circuit inside the lamp. It again seems to be a phase-fired controller. Believe me, I didn't plan this. It just so happens that phase-fired controllers are used everywhere where a light and cheap way of converting or switching AC voltages is required. Much to the dislike of the energy suppliers, since phase-fired controllers generate harmonics and act as reactive loads, affecting the grid in several negative ways. The faulty component of this circuit, however, can be seen by the bare eye. So, see how bloated the vent of this electrolytic capacitor is. Let's take it out and measure its properties. If you want to know if an electrolytic capacitor is faulty, you need to measure its ESR, or equal series resistance. And that's just what I'm doing here. According to my charts, a capacitor like this should have a much lower ESR, around 1 ohm. Its measured capacitance is also much lower than the rated 220 microfarads. These data show that the capacitor is barely working and totally out of spec. It is clearly overheated during operation, drying it out internally. After having removed the old capacitor, I replaced it with a new one of higher quality. With that being done, I temporarily attach the PCB via an IKEA AC adapter to the grid. As you can see, tada, it flickers. And with the filter and the flame-shaped plastic cover, it almost looks like a real-life fire. The only thing that remains here is to put it all together again. But that's boring and I'll do that off camera. The next patient is this Black & Decker Jigsaw. I bought it on eBay for under 10 bucks. The company doesn't have the best name here in Germany, but I recently worked with one of these when helping some friends to renovate their house, and I have to say I was impressed by its good performance. Maybe that's because it was still made in England, as the label says. Yes, you heard right. There was a time when England was an industrial powerhouse. And this goes out to my viewers in the UK. I'd love to see you guys producing things again. In that course, I have to say that I love the LCR meter I just used to test that capacitor. It's made by Peak in England. It shows that it is possible to have success with a product made in your home country in 2014. But enough of that, because I could go on about this for hours and I guess nobody can hear that anymore. The main issue with the Jigsaw is not its functionality, but the fact that it's super dirty. Therefore, I will now show you how you can get old machines like this clean again. After opening its case, we can see the saw's guts. It's again a gearbox attached to a universal motor. This time we have no control circuitry, just a simple switch and a single X-class capacitor, similar to the one I just put inside the Bosch angle grinder. This tool might be of very simple build, but as the inside reveals, it was built in 1994 and is still in working condition. Since we didn't take a look inside the gearbox of the reciprocating saw, we will take a look inside this gearbox instead. After opening the box, we see a reduction gear with a bigger cogwheel acting as an excenter at the same time. To show you its mode of operation and to show you at the same time that universal motors work with DC as well, I have now connected two 12-volt batteries in series to drive the motor. It's simple and beautiful, and the mechanism seems to be in perfect shape. I have seen gears of much lower quality in brand name Jigsaws. But now let's come to the cleaning process. To clean a mess like this, I simply use old-fashioned soapy water, based on washing powder dissolved in warm water. In this case, I maybe took a little much of the good powder though. But in general, I can recommend this method for cleaning plastic and metal parts of all kinds. After a couple of hours, I take the parts out of the water and brush the dirt off with an old toothbrush and some rags. After that, of course, all parts that were in the water have to be thoroughly dried. For that, I put them on top of my radiator for a couple of hours. In the meantime, I clean some of the internal parts, again with a toothbrush, but this time without the water. A blowgun would probably work well too, but my compressor broke down a few days ago, so this will have to do the job. Before taking everything together again, I will prepare some plastic pieces to later connect my Vorwerk vacuum cleaner to this jigsaw. For that, I roughen the surfaces of some of the plastic parts. Before closing the enclosure, I make sure that the cable, the switch, the filter capacitor and these nuts down here are sitting in the right place. With the enclosure being screwed together again, I can now glue the new adapter piece on the jigsaw. After the glue has hardened, I can now connect the vacuum cleaner and start cutting wood. This next repair is a bit off topic, but it's a repair, so it goes in this video. A couple of days ago I damaged the left side mirror of my Opel Corsa when parking in my garage. The lights weren't working and I bumped into a concrete pillar, breaking off the entire mirror. After that I botched it together and immediately ordered a new one. It only cost me 10 euros, shipping included. To replace the old one, it seems I simply have to pull off the paneling, unscrew a bunch of screws, take off the old unit, put the new unit in place, tighten the screws again and put the paneling back on, and that's it. Now I actually was planning on showing you how I repaired this thing. But I'm totally done for today and we'll have to talk about that in another video. No matter what, I promise you that there will be new videos soon. It won't take as long as the last time. So yeah, I hope you liked this and see you soon.